Hello, this is Jason with Maya. Today we're going to take a look at NX-CAM and working with a 4+1 configuration with a 5-axis machine. So that's 4 axes of motion, but one just used for indexing the position. So let's jump over to NX and get started. I'm using one of the delivered machine kits. There's a tab right out of the box that lists all the machine kits that are available. Here I'm using the Sim08. These all come with a sample part, all ready to try. You can tweak these and use them for your own machines, or use them as they are right out of the box. I've gone ahead and done some adaptive milling right up front to clear some of this excess material. And we'll just do a verify. And verify does not yet incorporate the full machine kinematics, so that wouldn't actually be necessary in this case because it's just a straight 3-axis operation. Got myself a little floor and wall operation. If I did create operation and choose planar, you would see that this would be the floor facing without wall, as the tooltip describes. And really haven't done anything to that operation. I might want to limit the runoff. So the search capability is really nice. If you happen to be on another tab and you couldn't remember exactly where the runoff is, you can just type it in and hit enter, and it'll take you right to that area, right to the panel. So I might give this a, I don't know, 20%. So that looks pretty good. I probably could even narrow that down a little bit more. So there's no point in cutting that extra way because we've already faced off that corner completely. This is just a good opportunity to show you how easy it is to reuse operations. I don't like to ever do a demonstration without showing some of the benefits in general. Just ease of use with the software. So we're going to simply respecify this one corner. Now, these corners would require multi-axis positioning, though it is only indexing, so you're going to get that even with your lower end bundles that are 2.5 axis or 3 axis. You wouldn't need necessarily a 5 axis bundle to do this kind of operation because it happens right in the post processor, and that would be available across all the packages. I might do a little shortcut here and simply mirror these operations through this plane. And we'll just grab them from up here and put them at the sequence that we want. So that's just a quick way to reuse those. I've done another adaptive, not an adaptive, but just a simple floor and wall operation here. Really nothing special. We're just using the follow part cut pattern, which gives it that nice consistent wall offset from the inward part shape. Pretty easy. You can see how that is. And then we've just faced off the top. Super easy. So let's look at semi-finishing this blade, but only using the A-axis. Maybe we should jump into the navigator and take a look at the capabilities of this machine. So we have X, Y, whoops, missed one. There's X, there's Y and Z, and we have A for trunnion and C for the rotary mounted to the trunnion. So we want to only use the C. There might be a couple of reasons you might want to do this. It might be more rigid. You can lock the A axis. When you start combining rotary motion, sometimes depending on the controller, you may not achieve full acceleration. Maybe you don't have that license in your controller. You only have a 4+1 license for the controller instead of a full 5-axis simultaneous. Whatever the reason might be, it's kind of a common thing that people like to do. So we'll go to our operation navigator. We'll create an operation, multi-axis. We'll use the guided curve. I'm going to use a 3/8 ball mill, semi-finishing method to leave a little bit of material for my finishing tool. I've already done a little finishing operation here. I'm going to hit OK. The guided curve just simply requires some curve to use as the guide. I'm going to set my part cut area right off the bat. And we can use a helical. And looking at the arrow, I can imagine my tool being on that edge, and I want to move to the left and cut away from the guide, so it will start here and move its way down. Pretty straightforward. We'll use maybe a scallop, kind of makes the most sense, 10 thou roughing. And then it's just a simple matter of using the axis and avoidance tab. And we're going to use 4-axis normal to drive. Simply specify the rotary axis. The rotation angle will allow you to lean that tool away from the tip, so the contact point won't be at the very tip of that ball mill, which is beneficial because ball mills don't cut very well on that very tip. That's the least efficient area of the tool. It sometimes can leave a little bad finish mark also, where they have very little gullet, very little area to cut. So we'll just hit OK. I want this to be right after my face mill, so I'm just going to drag that up so it's in the right sequence. And before we go into the machine simulation, we could just do a quick verify. You can see what that's going to do. It's going to semi-finish that area. Getting a little heavy into the corner, but that's okay. It's just a demonstration. We also have a variable contour that goes in and cleans this out. This is, again, using that same end mill, and maybe we'll send this over to the ISNV, Integrated Simulation and Verification. So this is going to incorporate the full machine kinematics. It's going to post the code in the background, which is why it took just a second for that to happen. And the verification actually then interprets all this directly. So it's especially valuable if you're working on your post-processor, making some tweaks. You can be guaranteed that the code that's being produced is going to work. So if we look over here in the axis dialog, we'll see that A axis is pinned just as we wanted at 90 degrees. And it's a little hard to tell, but we do have a little 10-degree lead for the contact point of that ball end mill. We could probably lean that in a little bit more if we wanted to. And certainly if we had any collisions, we would be able to check for those here. We could definitely show the material removal if we wanted to. Maybe we'll do that at the end. Now, I've got another operation here. This is interesting. This uses a tangent, what NX calls a tangent barrel tool. And the industry, sometimes you hear a circular segment or something like that. Essentially, it's a tool with a very large radius that can emulate the contact point of a really large ball end mill, but yet it has the form factor of a smaller, more conventional ball end mill. It has the advantage of allowing a very large step over and faster run time. So that's what I've done there, and what we've used for an axis and avoidance is relative to drive. And if we verify it, maybe before we tweak it, we should see that that gives us a really smooth finish with much greater step over than even that semi-finish tool. But if we send that to ISNV, turn the breakpoint off, you'll see that we have a lot of axis motion. And there are times, as we said, that you may want to avoid that. So let's see how easy it is to do that. We'll just double click the operation. We're in axis and avoidance, and we're going to use relative to vector, and the vector is going to essentially be pointing in the same direction as the rotary axis, and we want, I've gone ahead and played with this a little bit based on the shape of that tool. A 10-degree tilt puts it at a really nice contact point, and by limiting this maximum tool axis change, that will also further ensure that the other rotary axis doesn't get engaged at all. And we'll give that a second to generate. I really like that you have the ability to stop. If you see that a generation operation is taking way too long, you could have given it a bad input. It's nice to be able to stop. So at first glance, it looks less fluid than the previous operation. It's because, remember that the tool tip is what's being displayed here. But what's important is the contact point, and you can actually see, depending on the resolution that we've got the graphics set to, you can see that contact point is really good. It's right about in the middle. If I can click and hold. So it's right about in the middle of that radius, so we don't have any fear of running out of cut area. And if we did a 3D dynamic on that, it should look equally as nice as it did a moment ago. Very smooth. Probably would semi-finish this area down in here. That's kind of working my finish tool a little bit too much, but again, it's just a demonstration. Hit OK. If I wanted to, I probably could drag that up above that. And if we send it to the ISNV, we should be able to verify that we have pinned the A-axis to a 10-degree posture, and we're using a very efficient XYZ motion to finish that blade. So there you have it, 4+1 machining with NX Cam. Thanks for watching.